Hello everyone, my name is Nico. I'm a web developer focused on front-end development and WordPress. But don't worry, today I won't bother you with any WordPress fanboy stuff. I'm also founder of Say Hello. We are a little digital agency based in the Bernese Oberland. We do a lot of all the snacks today are on us. You're welcome. Thank you. What we do is mainly we develop websites and web applications for clients all around Switzerland. We are based in Bern or in Spiez, but we work for clients all over Switzerland. Well, and today I'd like to talk about, let's say, the evolution of web development. Because when the web started, roughly about 25-30 years ago, we had a very simple and very powerful concept where we have a server, and the server did all the heavy stuff, the server did all the database connection, all the rendering, the orchestration of our page, and we had the browser, and the browser had a very simple task. He just had to display what he got from the server. And between that we had the network, so we have the game of request and response. The browser sends a request, the server sends a response, and the browser will display that response. As I said, it's a pretty simple concept, it's a very powerful concept, and it works as long as we have interconnection. One thing, maybe, if you don't like GIFs, you will have a very hard time those 15 minutes. But as you see here, having no interconnection is really a really bad thing, but it's not even the worst thing. Having an unstable, flaky interconnection is way worse than having no interconnection, because if you don't have any interconnection, it's easy. The browser tries to send a request, and he will then display a network error. If you have an unstable interconnection, that would mean that the user stares at the white screen and it's loading and it's loading. It's just enough that the browser thinks he's online, but in the end it could be seconds, could be minutes, and he will just stay there waiting for whatever he thinks he will sometime receive. So today I'd like to talk about a new concept, and that's called offline first web development. And the thing here is, it's basically that one sentence. We should treat network connectivity as a progressive enhancement. That means that network connectivity, we can use that if the user is connected to the internet, but if not, it should not break our site. So it's not a critical part of our web application. And the whole idea is that we assume that our users will be offline from time to time, because they are. If you are on the mobile web, we still have holes and everything, and we don't have any interconnection. So if we treat every request as it should be handled on the client, we will it will help us a lot in the future development. So first, if we have a single page application, we need to think about what types of requests do we have. We have static files, which are the JavaScript file, a CSS file, some images, or even an index.html. Those are static files, which means that we have one URL, and behind that URL should be one file. And if that file changes, we should at least add another a version number or something, but that should be a static file. Then we have dynamic data, which could be a REST or GraphQL endpoint. And it's pretty clear that if you have the post endpoint, that could be like 8 posts, and if we publish a new post, those will be other 8 posts, so that's a dynamic endpoint. And we will handle those types of requests differently. First is, how do we handle static files, static requests? Therefore we have the service worker. The service worker is a new, it was introduced in 2016 I think, but it's still a very new feature. If we have the normal workflow, we have the browser that tries to send a request, we have network connection, and Chrome will display the dinosaur, which is pretty bad. With the service worker, we now have something that sits in between the website and the network, and we can also communicate with the application storage, which is also a new feature. So The service worker is also it's JavaScript, but it lives in a different scope. It's not on the window object, but it's inside the browser, and every request goes through that service worker and then communicates with the application storage. So if we don't have any internet connection, we still have a reliable source, which is the application storage for the moment. How does this work? As you see here, to register a service worker, it's very easy. It's basically one line where we call navigate the service worker register, and then we pass our JavaScript service worker, and it's one line, and then the browser will register our new service worker. Service worker then is event-based, so we have some special service worker events. The first one is the install event, which happens as soon as the browser installs our service worker. And we have the activate event as soon as the service worker takes control over a page or over a domain. And then we have the very important thing, the fetch event. So that event will be called whenever a fetch event, a request goes from the browser through the service worker to the network. And one other very important thing, when we register a service worker, we could also specify behind that a scope. So that scope defines what part of our page will be controlled by that service worker. Let's look at the fetch event, because that's the thing we need today. I have two very silly examples. As you can see in the first one, we have that event listener for fetch, and what it does here, whenever a request goes to the service worker, it will manipulate that request, and it will send a new response, which is basically just an HTML file saying hello world. So whenever, it doesn't matter, that could be a CSS file, JavaScript file, whenever some request goes to the service worker, he will respond with a hello world index.html. Not very useful, but might be funny to troll a coworker or something. Also, with the next example, there we take the install event, and inside that install event, we open up a new cache in the application storage, and we will put the cat.svg inside our application storage. But then, on the fetch event, we will check if the URL ends with .svg, and if so, we will return that cat.svg right from our device, because that SVG is stored on our device. And the thing here, it doesn't matter, that could be dog.svg, that could be whatever.svg. Whenever we have an URL which ends with svg, we will return the cat.svg right from our device. It won't pass the request to the network. So those are not examples I'd use in a productive app. If I'm using the service worker in a productive app, I'm using Workbox. Workbox is a tool by Google, and it's basically an abstraction of the fetch event and the caches API. So it makes it really easy for us. We don't have to handle all the cases, like if that request fails, you take that request. So it gives us standardized caching strategies. And we can say, let's say all images should be taken from the application storage first, and if there is no such image in the application storage, only then it would pass the request to the network. And those are those caching strategies. It makes it also really easy to pre-cache files. So if you have some files which are required for our application, we could pass those files to the pre-cache manifest. And also Workbox has a variety of cool plugins and modules, and it also has a Webpack plugin. So if we have our single page application with the application JSON and application JavaScript and some chunks, it would take all those files inside the inject manifest, and it would inject that manifest to the service worker. So we have those files inside our service worker and they are pre-cached. The browser support looks pretty good. It's only Internet Explorer that does not support, and even iOS joined the party a couple of months. I think it was about 1.5 years ago. took them quite some time to decide that they want to implement the service worker, and they did in the end. So we saved to use service worker on iOS, Android, on all the desktop and laptops. Even on Internet Explorer, if the service worker is not supported by the browser, it's not a big problem because it would just not register your service worker. But the app wouldn't break or something. But that's how we handle static files. Now let's get to the dynamic endpoints. We could now take the JSON endpoints and put those into the application storage. Could do that, but it's not designed to work like that. For those kinds of data, we have a database inside our browser. That's the IndexTV. In the end, it's a non-correlational database inside our browser. So what it basically does is it takes JavaScript objects, and we can store JavaScript objects inside our browser. And that's pretty cool, and I'll quickly show you how that works. Here as well, I'm not using the native API. I'm using an abstraction by Dave Archibald called IDB, which is basically a promise-based abstraction of the IndexTV API. And what we're doing here is, on the top, we will open up a new database, which is then called My Project. Inside the database, we have a store called Entries. And now we have some abstractions called the Get and the Set. Those, they both use the ID promise to put or to set or to get the object by the key. And one very important thing, when you have the service worker is something that just runs in the background and we don't have to care about it. With the IndexTV, that's something that works inside our application. So here we really need to specify for each fetch event what happens to that fetch event. So that's why I never use the fetch event directly. I always write a wrapper like that. A function called fetch API takes a key and it takes a callback, which could be a set state in the Preact world or just a state manipulation in Vue.js. And what it does then is it looks inside the IDB first. Okay. It looks like the IndexTV first, and if there is a response already in the IndexTV, it will just call the callback with the data it found in the IndexTV. And parallel, it also makes the fetch event. It goes to the API and gets the new content, the new object, let's say, and it will then store the new content inside the IndexTV. And it will also call the callback for the new content. So you can imagine we have a little flash here because we'll just take, first it will take the old content, then it will change the old content or exchange the old content with the new content. But the cool thing is the user doesn't have to wait because it's already on our device. It's there instantly. That example is from my own GitHub profile. I have my own website, Nico.dev, which is all the source code is open source on my GitHub profile. You can have a look there if you want to. It's a Preact app, but in the end it could work with any JavaScript framework or even with plain.js. So also IndexTV is supported by all major browsers, so it's pretty safe for us to use them. Now there's one thing you might be a little bit suspicious about. The problem is the IndexTV as well as the service worker, they are both there and we can use it without any interaction from the user. So maybe the user doesn't know that our website is putting files and data inside his store, and I mean, as we know on our device, it's not an endless place, let's say. So how do we know if those files we put in the store will be there forever, is persistent? For Android, there already is a solution. Since Chrome 55, Chrome will automatically judge if that site is very important for the user or not. And there are some criteria like if the user has bookmarked the site or high site engagement, those are criteria, and if one of them is true, Chrome will say, okay, that's a very important site, and I will keep that data for that domain. If not, it will be deleted from time to time. With iOS, unfortunately, we don't have such a process. iOS will always delete the data from time to time, which is pretty bad because you can't rely on the data we put inside the application search or the IndexTV. But normally we think normally our users are online, so if someone opens up our site, he will get the new content, and if then after some hours he tries to read that content again, it will be there. So it won't just be deleted after one page reload or something. So that was it from my side. I would really like to encourage you to think about how you could improve your website or web app with offline first technologies. I have two examples. One is the Webdevelopment guide, which is a view application I wrote for a client, and it's really cool. He decided to put the code open source, so you can use everything that's going on inside that view application, and also Nico.dev. Both apps are offline first, so they should both work with and without internet connection. Thank you very much for your attention, and yeah, if you have any questions, I think we will be there, or I will be there after the talk as well, or after the meetup, and yeah, thank you.